All right, in this video, I'm going to be doing the proof of the magnitude and direction of resultant of two vectors inclined at angle theta to each other. Now, we are going to be making use of two basic laws. That's the triangle law of vector and the parallelogram law of vector. Now, first of all, what does triangle law of vector says? Basically, triangle law of vector states that if any two vectors acting at a point are represented in magnitude and direction by the two sides of a triangle, let's say one vector is let's say this is the side of a triangle, right? And the other one is represented by this side, by two sides of a triangle, okay? Taken in the same order. In the same order means that this one is in this direction, they follow each other. That is head to tail, right? Then the third side of the triangle taken in reverse order. So this is the third side of the triangle. So this third side, now if this one goes like this, we would expect that the arrow should be like this. But no, the third side is taken in reverse order, all right? The third side taken in reverse order represents the magnitude and direction of the resultant vector. Okay, so this is R here. So let's take this one as vector P, and let's take this as vector what? Vector Q. So what triangular vector is saying is that, okay, let's call this side A, B, and what C. What triangular vector is saying is that as long as we have two vectors in the same order, the third side, which is in reverse order to the order of the vector, represent the resultant. So triangular vector is telling us that R is equal to what? P plus what? Q. That is that. But what about a case where the two vectors are inclined at angle theta to each other, which is the purpose of this? So how can we determine the magnitude and what and direction of the what of the resultant vector? So now we are still going to be making use of this concept. It's just that we are going to be producing it. So let's now say that this particular vector now is now inclined at an angle. So let's say we have it like this. So let's say we have it like this. Okay. Let's say we have it like this. Please don't mind my writing. Let's say we have it like this. So we know that this is R, right? So let's call this what? A. This is still B, and this is what? C. So this one goes like this one goes like this. Now, these two vectors, don't forget that this is the resultant. That's the resultant of the two vectors. But if these two vectors are inclined at an angle theta to each other, so for them to be inclined, then it implies that I need to produce the line of action of this vector. So if I produce this, so it implies a vector P will be inclined to vector what? Vector Q at an angle what? Theta, right? So definitely this has formed a kind of a right triangle, right? So let me see if I can make it better. This triangle doesn't seem to, pardon me for that. Let me redraw it so that it will make some sense. So it will be like this. So okay, this one is like this. So don't forget that this is still what? R. This is C. This is A. This is B. So this is Q. This is P. So for us to incline P and Q at an angle theta to each other, then I need to produce a line here. This is the line of action of P. So their angle of inclination to each other is theta. And then, so this is a right triangle here. And don't forget also, we also have another angle here, which is alpha. I take this as alpha. Alpha is the what? The direction of the resultant. Direction of the resultant in this case means the angle the resultant makes with the horizontal. So I say where alpha in this case is the angle of inclination of the resultant to the horizontal, which is the direction of resultant. Okay, then y theta is the angle between the vectors. So angle between, right, the two the two vectors. So with this information, we can therefore determine what we are looking for. So let's make use of this particular triangle now that we have angles involved. So we have our R. So this line that is being produced from B, we call this one what? D, right? So we need to find the value of what? R. We need to find the value of alpha, and we need to find the value of what? Theta. So to get R and alpha and theta, we need to solve for this right triangle ACD. So for the purpose of illustration, we'll say let BD be x. So we put x here, and let CD be equal to what? Y. All right. So once we are able to know those values, we can get our resultant. So what will be the resultant? The resultant here from represents the hypotenuse of this right triangle ACD. Right, don't forget it's a right triangle, so the side facing it. So we can say that the resultant, which is what? AC square, basically will now be equal to what? AD square, right, plus what? DC was square. Pythagorean theorem states that the square of the hypotenuse is equal to the sum of the squares of the other two sides. So if I want to rewrite this, I can write this as what? R square will now be equal to, what is my AD? AD is the sum of P plus what? X. Or let me say AD will now be what? AB plus what? Plus BD. Right? Then everything square, then plus what? DC square. So AC is actually R square. So we have R square, right? So we have R square will now be equal to what? What is AB? AB is P. Let me scroll down so that it won't lose is. So we have that AB is what? P plus what? BD, that is P plus X. Then everything was square. Then plus DC. DC is what? That is Y square. All right. But there is a challenge. And what is that challenge? BD and DC are two unknowns which can be determined from BCD. Right. So basically, we may need to use our knowledge of SOHCAHTOA. So I need the value of what? X and Y. That's BD and DC. So I can actually extract this right triangle BCD. So to be able to achieve that. So don't let me make it to lose. So from triangle what? That's BCD. BCD. So if I extract it out, okay, I can make it smaller. Okay, this is a right triangle. So we have B, we have C, we have D. So we know that CD is Y, and BD is what? X, and Y, this angle here is what? Theta, all right? And this is right triangle. So what we want to do is we want to make use of SOHCAHTOA again. So if we make use of SOHCAHTOA, if these are reference angle, this is what? Opposite. Then, of course, the side facing the right angle is the what? Hypotenuse. And this other side is what? Adjacent. So we are solving for X and Y. So for us to solve for X and Y, then we can say, um, uh, don't forget that we already know uh, B, BC. If you look at it, BC is actually Q. Don't forget that. So let me put it here. So we have BC, which is what? Q. So for me to solve for Y, so Y to Q, then X to Q. So I can say that what? That's opposite over hypotenuse. That is so. So in this case is what? Sine what? Theta, which is opposite. That is Y over what? Hypotenuse. That is Q. Right? So I can say that Y is equal to what? Q sine what? Theta. Then also uh, for that is for X. For X we have what? Car. How do I know it is car? Car is what? That is adjacent over hypotenuse. So that will be what? Cos what? Theta is equal to what? Adjacent, which is X over what? Hypotenuse. That is what? Q. So if we cross multiply, we have X is equal to what? Q what? Cos what? Theta. So So we know that this is y, I call it equation star, and x is what? Star, star. The purpose of this is we want to substitute it inside this equation. So the equation is not even far-fetched. And don't forget how we were able to get our x and y is from this particular smaller triangle here. All right. And okay. So because those are the spaces remaining. So let's just plug it into this. So we can therefore say that what? R square basically will now be equal to what? P, which we don't know yet, is a vector anyway. So P plus what? X, that is what? Q cos what? Theta, right? Then square plus what? Y square, that is Q sine what? Theta, then what? Square. Okay, so this is just the mathematics aspect of it. So we now have what? R square will now be, that's P plus Q cos what? Theta into bracket P plus Q cos what? Theta, right? Plus Q sine theta square, that will give us Q square sine square theta. All right, so let's open this bracket. P times P, that is P square. P times Q cos theta, that's PQ cos what? Theta. Q cos theta times P, that's PQ, right? Cos what? Theta. Then Q cos theta times Q cos theta, that's plus Q square cos square what? Theta. Then plus what? Q square sine square what? Theta. So at the end of it, we have what? P square plus PQ cos theta plus PQ cos theta, that is what? 2PQ cos theta. Then plus, we can factor Q square out here, that's Q square into bracket cos square theta plus what? Plus sine what? Square what? Theta. Okay, so having done this, from trigonometric identities, we know that was sine square theta plus cos square theta is equal to what? Cos square theta plus sine square theta, which is equal to 1. So that implies that whenever we see sine square theta plus cos square theta or cos square theta plus sine square theta, we can replace it with 1. So we can say that what? R square will now be equal to what? P square plus 2PQ cos what? Theta plus Q square into bracket 1. So this one can be written as Q square times 1, that's Q square. That we can rearrange this to be P square plus Q square plus 2PQ cos what? Theta. So that is the value of what? R square. So what does this imply? It implies that for any two vectors inclined at an angle to each other, the triangular vector can be used to determine the what resultant. I want us to note one thing, that this is not the same as the cosine rule, even though it look like it, but it is not the same. As long as the two vectors, the angle they are inclined to each other is known. How do I mean? For instance, if you have, let's say you have a vector, like this, you have another vector like this, and you are given this angle. As long as these two guys are inclined together at a particular angle theta, you use this formula, you get your result. And there are some other vectors whereby you have something like this, and you have something like this. So if this is the angle given to be the angle of inclination to the horizontal, this particular formula is still very what? Very, very much valid. So that is that about that. Now let's now look at how to determine the direction of the what? Of the resultant. How do we determine the direction of the resultant? Basically, the direction of the resultant is actually this. We are looking for alpha from this triangle, and we can actually determine alpha with ease. You can use either SOHCAHTOA and TOA. How do I know? Alpha is what you are looking for, so you can use opposite over hypotenuse. That's if you know your resultant. You can use adjacent over hypotenuse and the likes. So for me to now determine the direction of the resultant, all I will just do is I will just bring out triangle what? ACD. So let me scroll up a bit. So the direction, right, of the resultant. So let's see, how do we determine the direction of the resultant? So I said the direction of the resultant from the previous statement is the angle the resultant makes with the horizontal or vertical. But in my own case, I have actually inclined the resultant to the horizontal. So my focus will be the angle of inclination to the horizontal, which is alpha from this particular diagram we drew here. So the direction is alpha because it's inclined to the horizontal. So how do we now determine the value of alpha? So we just say from triangle ACD, we can determine alpha. We can what? We can determine alpha. So how do we determine alpha? So let me draw that particular triangle. That particular triangle will look like this. It's a pure right triangle anyway that comprises of other. So this is alpha. So this is R, don't forget. Then this is C, this is A, and this is what? D. And don't forget that AD is the summation of P plus X. Let me just scroll up a bit in case you did not jot it. AD is the summation of P plus X, and CD is Y, and AC is R. So that is very important to know. So we have that what? AD is P plus X, then CD is what? Is Y. So if alpha is our reference angle in this case, so this is our opposite. This is what? Hypotenuse. Hypotenuse is side facing the right angle, while the adjacent is the other side. Okay, so we can use SOHCAHTOA to get our alpha. So let's start with what? TOA. TOA in this case is what? Tan alpha. And tan alpha is what? Opposite over what? Over adjacent. So we can say that what? Tan alpha will now be equal to, what is our opposite? Yeah, that is what? Y over what? Adjacent. That is what? P plus what? X. So what is Y? Don't forget Y is what? Q what? Sine what? Theta. And then P plus X is equal to what? Q what? Cos what? Theta. So that is if we use what? Tan. And however, we can use car. So we know that car is equal to what? Cos what? Alpha. And cos alpha is what? Adjacent over what? Over hypotenuse. So what is adjacent over hypotenuse? Let's look at it together. Our adjacent is P plus what? X. So I can say that what? Cos what? Alpha is equal to what? P plus X over what? Hypotenuse, which is what? R. So if I decompose this, that would be what? P plus X is what? Q cos what? Theta over what? Over R. So this is another way to determine the value of alpha. So most textbooks often use tan alpha. No, you can use any of the three. So let me use this free space to determine the third one. Then we can also use so. So that is, so in this case implies what? Sine what? Alpha. And sine alpha is what? Opposite divided by what? Hypotenuse. So this implies that we can say that what? Well, I can say that sine what? Alpha will now be what? What is opposite? That is Y over what? Over R. And what is Y? Y in this case is what? Q sine what? Theta over what? R. So this one is actually useful when you actually know the value of the what? Resultant vector. So don't forget, R represents the resultant vector, alpha represents the angle the resultant vector makes with the horizontal, which is taken to be the resultant, and y theta is the angle between the two vectors. I want to believe that this video has helped someone. Endeavor to subscribe, like, you can comment and share the video. Thank you for watching. See you in the next video. Bye.